A circle is a 2D shape where every single point on the edge is exactly the same distance from the center. That distance from the center to the edge is what we call the radius. And if you go all the way across the circle passing through the center, that line is the diameter. The diameter is just twice the radius. Now, a circle has a few other important parts too. The chord, the tangent, the arc, the segment, and the sector. And there are 7 very powerful rules that connect all of these parts together. These rules are called the circle theorems, and they are one of the most commonly tested topics in GCSE Maths. Once you know them, you can find unknown angles and lengths in a circle without ever needing a protractor. Hi, welcome to my exam revision. In this video, we'll be discussing the 7 circle theorems. This lesson is divided into 8 sections. In the first 7 sections, we will go through each of the 7 circle theorems one by one, and I'll show you a fully worked example for each. In the 8th and final section, we'll work through a proper past paper style question that combines more than one theorem together, because that's exactly how these come up in your exam. I've added timestamps in the timeline below, so if you'd like to skip ahead to a particular section, you can do that easily. I've also included detailed notes in the description. If you'd like to go through the steps more carefully in your own time, you can click the link and follow everything step by step.
Now let's get started. Let's begin with the first theorem, which is the angle at the center theorem. The rule is this. The angle at the center of a circle is twice the angle at the circumference when both angles stand on the same arc. In plain English, if you take any 2 points on the circle and you draw lines from those 2 points to the center, you get one angle at the center. If you draw lines from those same 2 points to any third point on the circumference, you get another angle. The angle at the center will always be exactly double the angle at the circumference. Let's do an example. We have a circle with center C and 3 points A, B and D on the circumference. The angle at the center BCD is 150 degrees. We are asked to find the angle BAD, which is the angle at the circumference standing on the same arc BD. The rule tells us the angle at the center is twice the angle at the circumference. So to go the other way, we just divide. Angle BAD equals 150 divided by 2, which is 75 degrees. And that's the answer. See how clean that is. One rule, one division, done. Now let's move on to the second theorem, which is actually a special case of the first one. It's called the angle in a semicircle. The rule is this. The angle in a semicircle is always 90 degrees. What that really means is, if you draw a triangle inside a circle and one side of that triangle is the diameter of the circle, then the angle opposite the diameter will always be a right angle. Always. No matter where that third point is on the circle. Let's do an example. We have a triangle ABC inside a circle. AB is the diameter. The angle at B, which is angle ABC, is 67 degrees. We are asked to find the angle BAC. Step 1 is to use the semicircle theorem. Since AB is the diameter, the angle opposite the diameter, which is the angle at C, must be 90 degrees. So angle ACB equals 90. Step 2 is to use the fact that the angles in a triangle add up to 180. So angle BAC plus 67 plus 90 equals 180. Add 67 and 90, that gives us 157. So angle BAC equals 180 minus 157, which is 23 degrees. And that's our answer. Now let's move on to the third theorem, which is angles in the same segment. The rule is this. Angles in the same segment of a circle are equal. What that means is, if you take a chord, that's any line joining 2 points on the circle, and from each end of that chord, you draw lines to 2 different points on the circumference on the same side, the 2 angles you make at those 2 points will be equal. It doesn't matter where on the arc those 2 points are. As long as they're both on the same side of the chord, the angles are equal. Let's do an example. We have a circle with 4 points on it, A, B, C, and D. The angle DBC is 47 degrees and we need to find the angle CAD. Both of these angles are standing on the same chord CD and the points A and B are on the same side of that chord. So they are angles in the same segment. By the theorem, they must be equal. So angle CAD equals 47 degrees. That's it. No calculation needed. Just spot that they are in the same segment and you're done. Now let's move on to the fourth theorem, which is the cyclic quadrilateral theorem. A cyclic quadrilateral is just a 4-sided shape where all 4 corners lie on the circumference of a circle. The rule is this. In a cyclic quadrilateral, opposite angles add up to 180 degrees. So if you have a quadrilateral ABCD inscribed in a circle, then angle A plus angle C equals 180 and angle B plus angle D equals 180. That's the whole rule. Let's do an example. We have a cyclic quadrilateral ABCD. The angle at A, which is angle DAB, is 58 degrees. We need to find the angle at C, which is angle BCD. A and C are opposite corners of the quadrilateral. So by the theorem, angle DAB plus angle BCD equals 180. That gives us 58 plus angle BCD equals 180. So angle BCD equals 180 minus 58, which is 122 degrees. And that's the answer. Before we move to the next section, I want to quickly mention something that will help you practice this topic properly. On my website, My Exam Revision, I have created a full worksheet on circle theorems. It starts with basic foundation questions, then moves on to harder multi-step problems, and finally proper past paper exam style questions, all with step-by-step solutions. I've also built an AI version of myself based on my 14 years of teaching experience in GCSE Maths, A-level Maths and further Maths. You can check the step-by-step solutions, and if you get stuck, you can simply take a photo and upload your working. It will analyze each step, highlight where you went wrong, and even if your final answer is correct, it will still check your method thoroughly. If you're serious about improving your grades, I highly recommend trying it. The link is in the description. Now, let's continue to the next part of the video. We are now on the fifth theorem, and this one is about the tangent. Remember, a tangent is a line that just touches the circle at exactly one point and doesn't cross it. The rule is beautifully simple. A tangent meets the radius at a right angle. That's it. That's the whole rule. At the point where a tangent touches the circle, if you draw the radius to that exact point, the angle between the tangent and the radius will always be 90 degrees. This is one of the most useful rules you'll have because it instantly gives you a right angle to work with whenever a tangent appears in a question. And once you have a right angle, you can use Pythagoras, you can use trigonometry, you can use the angles in a triangle. It opens up everything. So whenever you see a tangent in a circle theorem question, the first thing you do is draw the radius to the point where the tangent touches the circle and mark that angle as 90 degrees. Now let's move on to the sixth theorem, which is the alternate segment theorem. This is the one most students find the trickiest. The rule is this: the angle between a tangent and a chord is equal to the angle in the alternate segment. Let me explain what that actually means. Imagine you have a tangent touching a circle at a point, let's call it A. From the same point A, you draw a chord across the circle to another point, say B. The angle between the tangent and the chord is the angle at A. Now look on the other side of the chord at any point on that opposite arc, say point C. The angle at C, that's angle ACB, will be exactly equal to the angle between the tangent and the chord at A. Let's do an example. We have a circle with a tangent DE touching the circle at point A. Triangle ABC is drawn inside the circle, so points B and C are on the circumference. The angle CAE, which is the angle between the tangent and the chord AC, is 56 degrees. We need to find angle ABC. The angle ABC is in the segment on the opposite side of chord AC from the tangent. So by the alternate segment theorem, angle ABC equals angle CAE. That gives us angle ABC equals 56 degrees. Just like that, no calculation. Once you spot the alternate segment, the answer drops straight out. Now let's move on to the seventh and final theorem. This one is about chords. The rule is this: if you draw a perpendicular line from the center of a circle to any chord, that line will bisect the chord, meaning it cuts the chord into two equal halves. So if the chord is say 10 centimeters long, the perpendicular from the center splits it into two pieces of 5 centimeters each. So those are all 7 circle theorems. Angle at the center is twice the angle at the circumference. Angle in a semicircle is 90. Angles in the same segment are equal. Cyclic quadrilateral, opposite angles add to 180. Tangent meets radius at 90. Alternate segment theorem. Perpendicular from the center bisects the chord. Now let's see how they work together in a real exam style question. We have a circle with center O. 4 points lie on the circumference: A, B, C and D. BD is the diameter of the circle. AC is a chord that is perpendicular to the diameter BD and they cross at a point E. We are told that BE equals 3 centimeters and angle CDE is 40 degrees. We need to find the distance x, which is the length from C to E. Step 1 is always the same. Mark everything you know on the diagram. BD is the diameter. AC crosses BD at right angles at point E, so angle CEB and angle CED are both 90 degrees. BE is 3 centimeters and angle CDE, which is the angle at D in the big triangle BCD, is 40 degrees. Now here's the moment where you have to spot which theorem unlocks the question. BD is the diameter and C is a point on the circumference. So if I draw the lines BC and CD, I've made a triangle BCD where one side is the diameter. By the angle in a semicircle theorem, the angle at C, which is angle BCD, must be 90 degrees. That's the key step. Without that, the question is much harder. With it, everything opens up. So now in triangle BCD, we know two angles. The angle at C is 90, the angle at D is 40. So the angle at B must be 180 minus 90 minus 40, which is 50 degrees. Now look at the smaller triangle CEB. It has a right angle at E because AC is perpendicular to BD. The angle at B is 50 degrees, the same 50 we just worked out, because E sits on the line BD. We know BE is 3 and we want to find CE. In this right angle triangle, the angle is 50 degrees. The side adjacent to that angle is BE, which is 3, and the side opposite that angle is CE, which is x. So we use tan. Tan of 50 equals opposite over adjacent, which is x divided by 3. Rearrange to get x equals 3 times tan of 50. Tan of 50 is approximately 1.1918. So x equals 3 times 1.1918, which is 3.58 centimeters to 2 decimal places. So the length CE is 3.58 centimeters. I hope you enjoyed this video. If you did, please give it a like and subscribe to our channel. We will be bringing out more educational content like this, so make sure to follow the channel. Also, don't forget to try the questions on the worksheet linked in the description. Thank you for watching.